Another is the of the critical flow. That's when the slope is mild to supercritical, or flow is from when the flow is mild to steep, and that is the critical to supercritical flow. And also, if you have a supercritical flow to subcritical flow, there is a creation of hydraulic jump. Or if the slope is from steep slope to sub or to, so there is a hydraulic jump, or okay, and that is the formation of the wave. And that transition of flow is from supercritical flow and to subcritical flow. So that is when we why we need, actually hydraulic jump is good solution when you have a long channel. You have to your water create a hydraulic jump. Why? Because we need to reduce the velocity of flow of the water. And it is also the time to separate the solids from heavier ones. So the sedimentation process will observe at this point. We need to settle down all the solids before bringing it downstream to avoid the damage of your structures. And have to think downstream, nanay mga valve, nanay mga structures diha sa ubos, no, sa downstream side, before you can deliver water different areas. Depende na siya sa water usage. So in that case, to avoid the damage of this structure, you have to lessen the velocity of the water and to reduce also the sediments brought by the water. Thinking, because this is an open channel, either Kalindain Canal or Anayam Canal, it still can cause negative impact if ever your water brings more solids downstream. Or there are some also, i-break name mo, you have to put some katong, you have to decrease the elevation na kay depression, or you have to create a hump also to reduce the velocity. It's not good that your velocity, the flow of your water is super critical downstream, because there is possibility kung imuhang water supercritical flow, it can cause scouring sa downstream side. So, mag-scour siya, tapos ang hitabo, ang guba po siya kuan structure. So, mo na siya yung purpose sa imuhang hydraulic jump. Okay. If we take a free body diagram of this hydraulic jump, you have to take note whatever formulas nga to ang makuan dire. This is only for a rectangular canal. Okay, so we have here a rectangular canal. And if we take the free body diagram of this hydraulic jump, you remember the impulse momentum, uh, the impulse momentum equation, or the effect of the impulse momentum sa inyong fluid mechanics. So this is also one of the applications. So you remember katong bending po sa pipe, if you have a curvature of your pipe, or if the flow of your water travels in a curved vein, in a curved path. So So, axis na to ani ang velocity are vectors. So, when you say vectors, you have the magnitude and direction. So, all forces that is going up and that going right, that is positive, and also your velocity. If your forces going left and going down, you have a negative direction. So we have to the direction if you remember things, no? So if we take the free body diagram of this hydraulic jump, okay, this is the jump. So you have here the wave creating the wave of your channel because there is a changes of the slope that is from supercritical to subcritical or from less than critical flows to greater than critical flows until normal depth will. So you have here yn because the depth here less than less than C. So this is critical flow. Diri dapita your A is greater than YC. So you have the critical flow until you have a normal depth. So here in the jump, the depth of flow can change from less than critical or greater than critical to a uniform flow. So you have to remember that after the occurrence of the hydraulic jump, uniform flow will be served after the okay. So just take a look of this. This the distance between this jump. So here, ang distance ani, this is very lang. Kanang sa tagani relatively small, no? Ato lang ni siyang gipadak-an yung dako. In the actual, it is relatively small. That's why the friction between the bed or between the wall of the canal, okay, we have here the friction that is negligible because, as what I've said, because of the distance. Ang iyang friction, ana. Okay, we have here the normal force and the one that is kaning the counteract sa imuhang normal force is the weight. Okay, the weight for you have here the weight. Okay, we have the weight and you have here the normal force. All forces, the one that counteracts that one is your friction force. Because there is friction exerted, no, between the fluid and the wall of the canal. As what I've said, we have to neglect this friction because of the distance that is quite small. Okay, so this is the hydrostatic force. Pag ana mo screenshot plus sa kay ako ra ba ning kuan ga-erase mo ko. Okay. So this is the hydrostatic of your fluid. So from here sa water surface, this is your water surface. The pressure here, if this is section 1 and this is your section 2, the pressure there is zero because it is exposed to atmospheric pressure. So that is zero. From what you've learned in your pressure at static sa fluid mechanics, as you go deeper, it will increases the pressure. So, lalong ang imuhang tubig pagkadako ang imong pressure. So, this pressure will be in the form of triangular distribution. So, you have that pressure. Okay, so here, this is your P1, and that is equal to, is just equal to the specific weight of the fluid times the depth, okay, times the depth of the fluid. So this is your Y, and this is your Y2. That is your Y1, Y2. As you go deeper, your pressure will increasing. So that is in the form of triangular pressure distribution of your hydrostatic force. So you have to remember this is the hydrostatic force. And this is also one of the applications you've learned sa fluid mechanics from forces acting on a plane surfaces. So I hope you remember that one. That is the force acting from a because you have two, you have force acting on a plane surface and you have force acting on curved surface. So here, the change of your the change of your forces of the fluid, the change of the momentum of the fluid, which is equal to this one, is the density of the fluid times the unit or the flow rate of the fluid times the velocity of that is going out, okay, minus the density of fluid times the density, the charge of the fluid times the velocity of the fluid that is going in. Okay, so that is the impulse and momentum equation. Okay, so the formula for this. So these forces F1 and F2, you have their unbalanced forces. And these unbalanced forces is equal to the rate of the momentum. This is the formula for the rate of the momentum. Okay, so we take summation forces at direction. So you have here F1 minus F2 minus friction, because you have here the friction. Okay, so we neglect, but if we ang imuhang ang inyong is the friction factor, you have to consider basta naa siya friction diha. But as what I've said, neglected because it is the distance of this hydraulic. No, the distance of this hydraulic jump is relative. Okay, this distance. Okay, so we have to neglect. This is this is the that is not E, that is friction. Okay, so looking back for the F1. Okay, looking back for the okay one for the force. Okay, for the force, okay, or pressure from the set of materials. We discuss man ang force dito. So, pressure is equal to force times area. So force is equal to pressure times area. So getting the formula for your F1, so you have here your F1, just take the area of the pressure. So the area of the pressure there is, so you have 1/2 P1 times Y. Okay, 1/2 P1 times Y. Where your P1 is gamma Y1 times Y1. So your F1 is just equal to 1/2 gamma Y1 squared. Times 1/2 Y1 times P1. 1/2 Y1 times P. Here, P. Times B. So we have that one, 1/2. So this is now the formula. So, muna dre, kakikan. Okay. You have y1, 1 half 1 squared gamma times d. The same sa imong p. If you remember also this formula, okay, so you have here for a plane surfaces, that is, this is your, that is from the centroid. So the force here just equal to gamma bar h times area. Okay, so your bar h is equal to 1 half y, right? And your area is y1 times the width of the channel. So we have 1 half y times the area is equal to b times y. So if we simplify this, you have 1 half gamma y squared times. So pareha ra siya o ta. Okay. Which is also this one. So pareha ra siya o resulta. If you use this formula, 1 half gamma times A. That is, if you, this one, this is an application of the pressure prism. No? Kung na-discuss na ninyo, that is also for the pressure prism. Uh, if you have a rectangular area, so no, that if you have a rectangular area, that is the force, how we will determine the force. This can be taken also when you have the force acting on the plane surface. Plane surface. Can see, yeah, this will be, yeah, this is sa, ano siya, sa pressure prism. Pressure prism ni siya. If you have a rectangular wall, so if pressure of water or the hydrostatic force of water acting on a rectangular surface. So it can be also applied. Kaning sa taas, this is thing on a plane surface. That is the formula kung ganda for this one is for pressure prism. So and apply also this one in getting the force of the dam. So katuing yung wala, I mean what you have learned in your force acting on the plane surfaces or the application of the pressure prism will be applied also sa dam. Hope you will not forget it. So again, your for water, that's hydrostatic force. So pwede na siya, any formula you can use that one. So we have here 1 half gamma y1 squared b for F1, and you have for F2 you have 1 half gamma y2 squared times b. So we will substitute this to this equation. So we will derive now. Okay, by applying also the continuity equation, because we are dealing here water, and water is an incompressible fluid. So we have here Q1 is equal to Q2. So getting the value or of your V2, so we can have this equation. So this is now the equation of your, or this is the formula of your velocity. This velocity is before the jump. This is the velocity before the jump, of course. So you can memorize this one. So it means once you have the depth, no? Once you have the depth before and after the jump, you can get the velocity of the jump. Okay, so again, we will use this one in getting the discharge. This discharge is the unit discharge. Okay, so that is the unit discharge. Again, if you are given, if you have the two depths, that is the depth before the jump and after the jump, you can determine the unit discharge. But since our Q is equal to Q times B, so we can get the discharge. This one Q, small q, is the this big Q is the discharge of the nut. So, you have to be careful kung ipangayo ani. This unit, cubic meter per second, this is per meter width. Okay? So, or it can be Q squared, sorry, it can be M squared or M squared per second. But here you have cubic meter per second for the Q. Okay, so you have the discharge, and now we have to get also the energy and the power lost in the tube. So you just take energy equation. Okay, the energy equation, then your head loss of the jump is just the difference between the specific energy of the water before the jump and after the jump. And power is just equal to P times specific water times Q times head loss. This is the formula in getting the head loss. Okay, so okay, this is for the okay getting the Q. So you have there the depths of flow. How about only one depth is given?
Sure, a friend was to the Facebook. If I do Facebook almost every
Okay, how about if you will be given the Q and only the other depth, you know? Or only give ihatag lang is only the depth of flow.
ito po siya, po. Sigurado mo.
Okay, so again, you only to apply the, because there are some sources nila formula, but para dili lang mo mag memorize, just take the image equation between section 1 and section 2. Okay, so our formula is we have to derive the depth of the hydraulic jump. So only one depth is given. So you have this formula. So from that formula of the unit discharge, so from the formula of the unit discharge, you just take, or you have to transpose that number, that value, the 2 to the left side, and also the acceleration, the depth before the jump. So once you have that one, you can have this equation, and you can have this equation, and this is also can be simplified. Okay, this can be simplified, and it will result in the fruit number.
Excuse me, ma'am.
Okay, you have that one, two, so 2 square G1. Okay, 2 per square G1.
Okay, ma'am.
Excuse me, ma'am.
Ah,
Murag wala ka gimok, ma'am. Itap gore ang screen.
Itapot ang screen, ma'am.
okay, so you have this formula, but this one can also be simplified. So we have your 2 square G1, 1, 3. So, okay, this is 1. Okay. So, when you derive one, this will result to over b over 0 of g y. So if your flow is that for statistical, your depth also critical. But if it's not critical depth, so your velocity also is not critical. So that is the formula for the fruit. If you square this one, so the result is equal to v squared over gy. So the final derivation is this one. So the depth of after the jump is equal to 1 half y1 times negative 1 plus square of a. You have to check. That the food number is greater than 1. So that is greater than 1. So the your here is less than C. So that is y2. So if this y is less than y3, that is supercritical. It should be that here your fruit number is greater than 1. And for the depth before the it should be that the Reynolds number, sorry, that the fruit number is less than 1. So kung dili siya less than 1, ang inyong depth of flow is no hydraulic jump will occur. You have to remember, bisag ipangutang siya sa problem, nga what will be the depth for the jump. Pero, pag solve ninyo, you can, that answer, you can answer that question, you can answer, there's no hydraulic jump. Necessary nga po, sige ra mo, basta ragod mo solve. Mo na siya ipangutana. Not necessary nga mag-solve mo because kay pangutana, you can answer, yes, the jump will occur. So, the depth before the jump is equal to like this. Pwede po mo maingon, there's no hydraulic jump will occur. Why? Because the Reynolds number is not less than by 1. So, pwede diha na ang inyong answer. Okay, so, again, this problem can be applied only for rectangular sections. Okay, so para na siya sa rectangular sections. For the rectangular sections, we will go back again from the derivation. So here, from here, you can diha This is the area. Then we break it down into by because the area is equal to by because the canal is rectangular. So in this case, we have to retain kani siya i-retain ra na natin as area 1 of area 2 because we don't know the type of the channel. So it is not rectangular channel. So just retain the area and area 2. So your equation will be retaining area 1 and area 2. So you have here, this is the hydraulic jump in a non-rectangular section. So take note mo class, depth or the location of the centroid, that is the location, okay, from the water surface. Okay, kan diha tulong na siya sa water surface. That is the location of your centroids of your channel. So if you don't know the location of the centroids of the channel, like trapezoid section, so ang inyong buhaton is to bisect. Inyo siyang i-divide ang triangular into rectangular and triangular because mo na siya basic. We know centroid of the, diba, if this is your trapezoidal, we will divide it. So, pwede ato na siyang i-divide. Then get the centroid for the water surface. So if that is the centroid, okay, that is from the water surface. Okay, that is from the water surface. And also here, okay, that is from the water surface. If you know the location directly of the trapezoidal, so you have to memorize the formula. We have a formula, the trapezoidal section for the centroid of the trapezoidal section. So if you know the location of the centroid, okay, Rocco, if you have the formula. Pero kung for me, you have to the centroids by dividing the section. Easier for you to memorize the basic. Basic na mga formula. So this is for the non-rectangular. Okay, so again, I told you to retain the area. So we have this equation, and for the velocity of the jump, you have this equation. Addition of interchange, interchange ang numerator, interchange for the denominator. So you can either of the formula. Next sa ko class sa akin, Pinawala akong screen.
Wala, ma'am.
Okay, so you can choose either formula. So, pwede na ninyo i-interchange. Okay, so another is this one. Okay, you can use this one. That is q squared over g is equal to a1 yc1 and yc2 times 1 over a2 times 1 over a1. So that is the formula for the non-rectangular section. But you can still apply that formula for rectangular section. So more or less that is the general formula for the computation of the discharge. Okay, so please take note na lang formulas. Okay, so we have here different for problem. We have here a problem. Okay, so we have here a rectangular channel with a width of 4 meters at the depth of 1.2. So adjustment is made downstream to raise water level to 2 meters. And nasa hang slope. Okay. Naasa yung slope adjustment sa kuan. This will cause hydraulic shock. We will calculate the discharge in the canal and we will determine the power loss in the shock. So here we can illustrate problem like this. So we have 1.2 that is the depth before the jump, and after the jump you have a uniform depth of so okay. You have to be careful. There are some depth na ipanghatag sa problem niya. Pero that is not the pasabot. That is not the depth for the jump. You need to compute first the depth before and after the jump. No, naay nun one. But in the problem, we assume that the depth before the jump is 1 meter. And the depth upon adjusting the level. So, because it is said, siya o jump. Okay. Pag-adjust niya, so nito siya kay hydraulic jump to 2 meters. So, we will assume that this is the difference for the jump. because of this statement. So we have here, we have so that is before and after the jump. So we see if we check cross section or the side view. But if we try to see the left side view, we can have this rectangular section. So you have here that is one, and we are talking the same here. So we have 4 meters width. Okay, so since two depths are equal, are given from the equation, as long as you have two depths, that is the depth before the job and the depth before and the depth after the job, you can get the discharge directly. Before getting the discharge, baon pa ninyo ang net discharge. So, we have the formula Q squared is equal to 1 half GY, 1 Y2 times Y1 plus Y2. So, we can compute the Q squared. I have to tell you, please don't write like this. So, if you have this one, 6.132, that is cubic meter, that is meter squared per second, because you can cancel man the per meter width, or you can say 6.138 cubic meter per meter width of the channel. Don't put this symbol. The same with sa inyong exam last time, the diameter is 0.159 mm, and you will say 159 meters, and is equal to 159 mm. So if you write that way, is palihog kog basa. If you write that way, unsa imong basa anin is
1 ma'am. 0.1 meters divided by 159 mm.
interpretation. Okay. Say like this, what is the meaning of this when we sa mathematics? So katong usa divide. Ano banono? Unsay pasabot kahaan?
Like
Okay, so
per
divide dayon pair unsa pa? Sa pailain meaning this.
Come on.
Unsay meaning ana para nimo?
I think more na mo ang divide or square.
Okay, tilo sila in meaning ani tilo.
Ratio day, ma'am.
Okay, it can be ratio. Okay, divide the ratio. Unsa pa? Lain? So, see, kung kamoy mag-check, ako mag-check, it creates another meaning. No? English, lahi po na siya. Karon og main kang unsa ni? Mingon kang tawagan mo yan. English, unsa man na siya kuan ani meaning kani unsay meaning ana sa English?
Or,
Flash.
ma'am.
Ha?
Sorry, or.
Or dayon
Slash.
Slash dayon.
Slash.
Okay.
Pwede put over, ma'am.
Ha? No, sa tagay ko
Kanang
tagay
over.
word nga mingon mo nga gamit mo ani kanang slash. Nalimot man ko sa to ako na sa mga sa ito. Ah, tagay ko sense nga mo gamit ani na ay slash. Nawala ako sa una. Anyone insay mo kuan kada mo hatag o slash o asa ni
Pwede po synonymous, ma'am.
hmm? Kanang mo gamit o select sentence bang na slash.
Ay,
Nag-
there mo.
Kanang mo write ang sentence nga kang slash.
Kanang he, she,
Oh, hindi sa siya. Wala ka na. Ha?
ano, ma'am?
Kana, ini, he or she. English na. Diba? Kani siya, kung sa English na, or galing lang na magutas mathematics. Natabag, kini siya, lahi na siya, or meaning, kung naata sa solusyon. Wala man ta sa English na to, kung ta write up, naman ta, gasolve man ta. So, munang dili ko musulot nga nagini ang inyong presentation, pag-solve, or pag-present sa inyong final answer. Because it can be divide, or kay gawin man tas, wa man ta ga write ang sentence. Wala man ta sa English na to. Pareha na siya o technical paper o letter. No? Puro na mga write-ups, pero may kang letter o technical paper o letter na siya. Lahi na siya o definition. Pareha sa bisatuan. Ang or o ni lahi ko na siya. So manang di ko musugot. So I hope you to take it down. Okay? Pareha ra pud na bahay. Kani. If you solve the okay, pareha pud ni class. Ngayon kang S is equal to kung sa range siya ani kang 1 okay 1 ano lang sige 1 divided by x over 2x over unsay diferensya ana mubasa mo unsay pasabi niyo ana sa
By
1 term
quantity na, ma'am.
ha
The quantity of an over x divided by the quantity of 2x over 3.
mao na imong interpretation kung kana
Ay, ma'am, maybe kasi sanang sa equal sign, ma'am, if imo na siyang ipang
Amo na
Anong-
siya. Muna yung
ito nga,
akong
ma'am.
bikuan. Ang proper na, kung mauto imong giistorya, kinahanglan ang ikay na asa ko nga. Kay kung katong equal, so kung katong imo ang equal sign na ari sa taas, no? So, it gives you another Okay. Question ni. It can be kani mo ni siya imong term. So that is 1 divided by x over 2x over 3. So kani siya mga kauban. So makimong kang kani mo imong division. So munang you have right. Mo bitaw ng sa algebra pa lang daan kung inyong maestro kabantay mo, istriko kay ng inyong maestro nga inyong equal sign diha jud na ibutang kung asapit na inyong operation o divide ba na siya. Kinahanglan na siya sa tunga. Na siya. So you have to follow. Ayaw ninyo na kalimti. Nang kay it can create another meaning. So ana ra Japon. It gives another meaning. So you have to write it. Okay, write it. So kung anak magaling mo, so maybe you can say or so pwede ba or per second or that. You have to write the word. Okay. So again, this is the Q. That is the unit discharge. Pero ang gipangita sa kanal is the big discharge. So we have the big discharge. That is QB. So that is 6.138 times the width of the channel is equal to 4. So that is 24.552 cubic meter per second. That is the answer. Another power. Okay, the power. This is head loss. Ang head loss nimo is just equal to the change, no? The change of the specific energy. Asa na gikuha, giderive na siya. You get the energy equation from section 1 to section 2. So just get the difference between the specific energy and the specific energy before the jump and the specific energy after the jump. So we have here the formula power loss. So HL is equal to E1 minus E2. Your specific energy is equal to Y plus V squared over 2G. So we need to determine the V1. Okay, so what is the V1 and V2? So paunin mo ang V1 and 2. So, pagkakuha nimo sa V1 dito, makuha nimo ang energy 1. Makuha po nimo ang energy sa section 2 or that is the energy after the jump. Then, you determine the difference between these bowens or this specific energy. So, once you have your head loss, you can have the power loss. So, since wala man gid butang sa problem ng power will be in power. So, you can answer in kilowatt or in by watts. So, pwede ra na sa wala man kay kuan. Wala man kay So, that answer is 12.765. If you like to convert it in HP, you have to convert it into then divided by 746, that is in HP. So that is the answer, 12.75 kilowatts. Okay, so that is the answer of problem 1. Okay, I have here another problem. Okay, so we have hydraulic jump of force in a 5 meters wide rectangular channel. So the discharge ng 6M3 cubic na siya ha. Kay man po ka kuan dire ka type of power. So that is 6 cubic meter per second. Then the bedrock is 0.005. Specify the depth after the jump is 1.4. So pangitaon na to, what is the depth before the jump? Akong gingon ninyo ganiha, even gipangutana ka, what is the depth before the jump? It doesn't mean nga inyo siyang ansiran. Maingon mong, therefore, the depth before the jump is equal to, anak mo, butang mo. Because it can be answered there's no hydraulic jump will occur. So there na possibility na moingon mo nga wala hydraulic jump kani occur. Pwede na mingon mo nga wala hydraulic jump kani occur. So that is your possible answer. Di gyud ninyo ipugson nga mo nga the depth before the jump is equal to 1.2. Dili na. Tan-awon ninyo kung naa ba mo yung answer. Ay, mga tricks, no? Ay, mga trick na rin ka ng mga questions. So, you have to be careful. Okay, so, then we have to calculate the power loss in a jump. Then, inyong ansiran. Ano ninyong power loss na wala hydraulic jump? Diba? So, ang answer ninyo can be, there's no hydraulic jump, so there's no power loss. So, mura na siya ang utana. So, you have to be careful. So, we have here 1, ang ipangutana, y2 is 1.4, kaya ningon man siya nga. The depth after the jump is 1.4 meters. Calculate the depth before the jump. We don't know if there's hydraulic jump, of course. Ang ako rang nabalaan, after sa hydraulic jump, normal flow will be observed. So, ana. So, here, still rectangular channel. So, you have 5 for the width and you have y as the depth flow. Okay, so the given, you have 6 cubic meter per second and the slope is 0.005. So, you have the problem. What you're gonna do is to apply katong formula gana, determining the depth before the jump. Okay, that is y1. So, find y1. It's not y2. y2, y1. The depth after the jump. After the jump, that is y1. Okay, so this is the depth before the jump. That is the formula. Okay, we have here the Reynolds number. Okay, so you have y1. So we have here the depth. No? Kay depth y2. We need to determine the Froude number. What is the formula of the Froude number again?
Velocity, ma'am, over the square root of d.
Okay, that is only for, can be applied only for
Rectangular channels.
It is that rectangular channel that is equal to
Denominator by GA over B.
okay, so you have to remember remember okay, so we have here if your depth is critical, so to have a critical depth. If you don't have a critical depth, so unsay velocity ni diha. So ako na lang ni Osborne. So this is square root of y. So kung imong depth is critical, imong velocity also critical. So we need to get the area para kakuha ta og velocity kay given minimum q. So velocity is 0.857. Okay. That is V2. So given ang y2, you have 1.4. You have 1.4. Okay, so this is 0.857 divided by square root of 9.81 times 1.4. So fruit number is less than 1 0. So what is your statement there? Hmm? Ano sa statement ninyo din?
Hydraulic force.
Yeah, don't jump, of course. How about the others? In F1.
No hydraulic jump, ma'am.
No hydraulic jump. So you have to think once I answer there. What is your final answer?
There's a hydraulic.
There's hydraulic jump from K na conscious sa condition
Hydraulic
nga
jump, ma'am.
NF2 is less than 1. Na makuha nimo ang Y1.
Hmm? The answer nito, point.
Point 2, ma'am.
That is point 2. Point nga ba?
0.23.
231, ma'am.
So that is less than. Okay, so again, what is your final decision?
Jump, of course.
Hydraulic, ma'am.
I don't jump first.
Yes, ma'am.
Stop. Okay, so hydraulic jump will equal. So the depth before the jump is equal to 0.136. Okay. So if the fruit number is greater than 1, so there's no hydraulic jump core. So you have to be careful in this problem. So kuan siya, gipangayo. Pero it doesn't mean inyo siyang ansilan. Okay, so okay, ako rin biwasan. Nakabay lang ako biwasan. Tanawa na to sa number 1, ha? Tanawa niyo. Okay, energy man. Tanawa kung inyong panon, sa dako ang energy, ang section 1 or section 2 is the energy before the jump or after the jump?
Before.
That is because of the loss of energy. No? Because of the loss of energy in the jump, the total energy after the jump is less than the energy before the jump. So kung yung tanawon that is 2.533, that is the energy before the jump. And after the jump, that is 2.480. So kung pangutan-on mo no, o tanon, what is the what happens to the energy before and after the jump? So we will answer na the energy of the jump after the jump, no, the energy after the jump is lesser than compared to the energy before jump occurred. So, pwede mo maingon because the alternate stage or the alternate of flow before the jump is equal to the depth of flow after the jump. So, kung iyong kaon, nigamay ang imuhang energy after the jump because of the loss during the jump. So, muna siya imuhang bantayan usahay. So, pangutan mo. So, usa na sa mga pangutanas kung naawin. Pangutan mo mga practical questions. Kaya kung wala sila ay loss, i-neglect nimo ang loss, so wala siya ay loss. You can derive head loss. Pwede po ng kuan. You can derive the formula of the head loss because here our head loss is expressed with the energy. Basta lang ha, ning kuan lang dyan ninyo, that is only the difference with the energy. Pero kung naamo na kita ng source niya, the head loss is expressed between the depth of flow lang, you can derive those formula. Asa man nagikan pag-derive, that is also taken from the difference of the energy. Gidagdi lang siya o kuan kanang bali ang imong velocity imo siyang express into depth of flow. Yun sa man pagkuha nimong velocity into depth of flow, we have formula of our velocity nga gihatag ang unit charge. Ang unit discharge na to plus express po siya sa depth flow before and after the jump. Hantod na ang imong kuan equation sa imong head loss is equal to the difference of this depth, no? Kana siya. So na kung tagaan mo og depth of flow before and after the jump, pwede na mo makakuha og head loss. Pwede na ninyo ma-derive siya formula. Or pwede po, no? Maybe at the end of the class, pwede mo na ako pa-derive on. Pwede sad, no? Para mo maka-derive. Because as what I've said, most of the formula of this topic, puro na siya derive. So, pwede, no? Before tamo din, derive mo na ako para makapractice mo ang derive. Okay, so we will continue the okay, ako man. So, we will continue. That is my one. So, the head loss there is the power loss. For power loss, power loss na jump. So we have P, gamma, Q, HL, K where L is equal to V1 minus E. Pero kung di na mo gamit ang na formula, pwede po ni kanin in terms of y because you already have your y. Maybe I will have a follow-up question later on kung pasulayon mo na po pag-arrive. Okay, so you have E1. So your E1 is equal to y plus V1 squared over 2G. Ano nga ito ang V1? Para laser, ano yung okay, we don't have the V1. So we need to determine the V1. So V1 is
Excuse me, ma'am. May pilit na po, ma'am.
Pinipilit mo sa okay, you have here V1. 6. So 6 divided by 5 times 0.136. So this is equal to, and you compute, as a calculator. Eight per second. So you have that is equal to then that is 1.36. 8.82 per square over 4G. Is equal to how many?
Four point zero five.
Okay, 4.175. And for E2, we write 2 plus V2 squared. Okay, so I write 2. Lang nakapagkasulatan. Okay, so 2 plus V2 squared over 2G. Y2 1.4 plus V2 is 0.57. Pila man yun? Seven?
7, ma'am. Yes, ma'am.
Okay, so head loss is equal to E1 minus E2. 4.105. Imagine, ako kayang pagkamay. The energy before the jump, that is 4.1. After the jump, that is only 1.437. So it is very small. So 4.105. Okay, that is 2.668. Okay, meters. So thus the power is equal to Q. So we have here 9.81 times 2, 6, 8 times 2.668. So that is equal to 81. 6 times 2.668. That is 157.03. This is kilowatts. Okay, that is sakto plus. Kiloko.
Yes, ma'am. Sakto, ma'am.
Okay. Kadyo ako i-check. Okay, so 6:42. What I gonna let you do? So this is the answer. 152. You can practice this na lang. Kaya we only have 15 minutes na lang. You try to derive in terms of depth na yan, derive head loss. Okay. In terms of depth, derive head loss of the jump in terms of depth before and after the jump. So it can be this is equal to y2 minus 1 cube divided by 4 by 1 by 2. Okay. I want you to derive this one. Note mo sa next topic, puro derivation siya po ng mga formulas. Okay, so that is the answer. Then you try. Pwede na ninyo ibutin yung compilation. Try lang for your practice. So ako nga side class ganan kay ko magkuan mag-derive. No? So ako na nang gi-derive ng formula para dili kayo mo makuan ba. Kaysa sige mag-memorize. Unsa ray mga principle ani class? Only the principles of momentum and the energy equation and the continuity equation. Nga nagasugod ang ato ang mga formulas for this topic. Sa fluid measurements, the same ra pud na. Ang mga formulas po sa fluid measurements, puro ra pud na siya gipang-derive. So, pwede dili na kaayo mo memorize ang mga formulas. Basta, ang gigamit lang, energy equation, continuity equation, because we are dealing with water. For hydraulic jump, we have the impulse and momentum equation. So, the unbalanced force acting in the fluid is equal to the change of the momentum. So, diha raga good. So, diha raga ko ang mga formulas dito. Okay, so, any questions? Ako ni off. Wala na may questions? Napatay 15 minutes break before ka magpan sa ato ang klase. Okay, so wala may class. Nalibog na ko na akong screen. Ano ni? Ako nakita di ikaw baga ako nakita. Kasi yung nakita baga man ako nakita din. Kabal mo ano ni akong screen. Ini.
Ang kanak mo.
Ha? Dili na ko kita. Ikaw ako nakita ni baga. Sa
Ang kanak mo.
nag-share screen ka?
Wala, ma'am.
Ano ni? Ano kabalo? Ano siya? Okay, so unsa man I have end the this sani takes at 15 minutes at 13 minutes. Kabalo nga yun. Ano na eh, si bago ko nakita under eh. Ano na yung tanawa akong screen.
Wala na ka naka-share screen mo.
Wala, ako nag-off. Ang tanawa ako ninyo. Tanawa, kita mo sa akong screen.
Pin ni mo si Baga, ma'am.
Ako na pinulaan o di na pud o. Na o di na
Napili
pud.
mo.
Masa may pag-unpin.
Pin mo siya, ma'am. Gusto to nga, ma'am, picture mo.
This one? This one?
Siya,
Ano?
kana, ma'am.
Wala, ma'am.
Yes.
Okay, thank you. Nalibog na. Muna akong screen. Ano yung screen? Ini yung screen class. Ako i-share pa
Cellphone
dito.
lang, ma'am.
Insay gapuan ga laptop. Asa na po to screen. Nabaguhan ko sa kuan. Asa mo share screen?